Welcome back, everybody. Last time I explained very quickly a magic trick that we could use to turn futures into try, or we could have started with try as well and converted that to futures. What we're going to do now is we're going to use that same dualization trick on the right hand side of our square of effects, and we're going to use that to turn iterables into observables. So that's the thing here on the right. Let's recall what iterables are. Iterables are a pair of traits. The first trait is iterable, that has a factory function to create iterators. So that's the function iterator, which returns an iterator. And then once you get an iterator, you can call hasNext, which returns a boolean, indicating if this iterator has more elements. And when hasNext tells you true, you will call next to give you the next value. All right? So it's a pair of traits that represent collections. And you see here, in this case, because you call next, these are pool-based collections. You're pooling every time for the next element. And to go back to our little game, imagine that we have a list of coins. A list is a kind of iterable, so there we have our iterable of coins. And once we want to pull out the coins out of our wallet, we have to first get the iterator, and then we go typically in a loop while there are more values in the iterator. We call next, and that's the way we collect our coins. Now notice that this is a synchronous stream or a pool-based stream. Every time we call next, we block until the next value is produced. And we'll see the consequences of that later. But of course, the first thing we should note is that iterable is a monad. And why is it a monad? Because it has flat map and it has a constructor to take a single value and inject it into an iterable. And of course, just having flat map and a constructor is not that interesting, and iterable supports all the methods that we know and love, like filter, map. And then there's the domain-specific ones, such as take, which takes the first n elements, or take while, that takes a boolean and iterates over the iterable, copying the values as long as that predicate is true. And then last but not least, there's our friend zip. Now, the nice thing here is that iterable, since it's an interface, there's many concrete types that implement iterable. Okay, so many concrete types that implement iterable, and we can forget about all these concrete types and just think of iterable as a collection. Okay, so any type that implements iterable is a collection, and we can draw that collection as a picture like this, where we have a line and then there's the subsequent elements. And map takes a function, in this case a function that turns marbles into diamonds, and applies that function to every element of the list. And the beauty of interface-based programming is that it doesn't matter what the underlying collection is. And in fact, very important, there might not even be an underlying collection, because this iterator will produce the next value on demand. So this is the beauty. There might never be an underlying collection like a list or an array. You can just create them on the fly. Now let me remind you of the typical execution times of a PC on a human scale. Remember, sending packets took a long time. Reading from memory took a long time. And what we're going to do now is we're going to use iterables to read stuff from memory. So here's the example. Read lines from disk, takes a path, and returns an iterator of string. And this is just the standard Scala code. And then we're going to do a for loop to do work for each line. Now reading from disk takes 2 weeks, so 2 weeks per line. That's kind of crazy because we're blocking again. We're waiting for a long time. So reading from a file using iterators is not a good idea because the latency is not, this is not the type to deal with things that have high latency. So what we want to do is we want to use our magical dualization trick to take this type of iterables that are synchronous streams and turn it into a type that represents asynchronous streams. So things that have high latency. Just like we went from try of t to future of t, we're going to go from iterable of t to a new type, and that's observable of t. All right, so the first thing we're going to do is we're going to simplify. And if you look at the iterator type here, this has next has no business there. We can simulate this by having next return an option of t, and if has next returns false, the option is empty or nothing, and if it does return a value, then it's just t. Okay, so we can take these two methods and turn them into one. Now whenever we see a trait that has a single method, we can turn that just into a type declaration. There's no need to have a complete trait. It's just, you know, this thing is just a function from unit to option of t. So let's just define that as just a function from unit to option of t. Now we can substitute that function, that type, because, you know, if it's just a single function, let's substitute it there in iterator. And now we have a trait that also has a single method, so just let's expand that. And now we get a type iterable that's really of type unit, arrow, try of t. All right? So what we have done is we've just simplified the trait iterable and iterator, and the essence is just this higher order function. Okay? I've done nothing special. Okay. So given these two things, we have simplified it into something that only has arrows. And the reason I wanted to simplify it this way is I'm going to use the magic trick of dualization, and that means I have to reverse the arrows. And now I have my type in a shape that only has arrows. So here we go, iterable, unit arrow, try of option of t. And now we're going to go and switch the arrows around. See you after the break.